Okay. Let me erase this first part. All right, so this is about where you left off. Okay. So you can't divide by a matrix, so you can multiply by the inverse. So remember, 3 times a third, 3 times its multiplicative inverse is just 1. It's also the same thing if I do a third times 3, that's also going to be 1. Yeah, so talking numbers, we understand that part. So that's what this part up here is saying, where it's, if you take A times B and you get your identity matrix, and then you multiply B times A and you get an identity matrix, guess what? They are inverses of each other. If you take 2 matrices and you multiply them together, first you have, you multiply them in both directions. I don't know if that's clear what I'm saying. You take A as the first one, and multiply by B, and you get the identity. Then you take B, multiply by A, and you get the identity. You could say that they are invertible. Right? When you multiply them together and you get the identity matrix, that's how you know they're literally inverse matrices of each other.
So when you multiply them together and then your matrix.
And if you don't get it,
that one diagonal thing.
Yep, that's how you know they're going to be inverse. This is how you check. Bella, put away your computer. All right, so example 2, determine whether A and B are inverse matrices. So in this example, in order to determine if they're actually matrices, you're going to multiply them. And if they are inverses, what should we get?
1.
We should get the identity matrix. And then when I reverse the direction, instead of having the first matrix, then multiplied by the second, we'll have the second matrix listed first. And then you guys understand what I'm doing with my hands? Literally,
You switch them back.
instead of saying 3 times 1, we'll have 1 times 3, and I should get the same thing if they're actually inverses. Okay. So,
Wait, I have a question.
yeah.
On that part, that last section that you were just talking about like a matrix times the identity matrix equals that original matrix. How is that possible if the identity matrix includes 0? So wouldn't that like cancel out a bunch of the parts of that first matrix?
No,
No,
it doesn't. Okay, if I have time at the end, I'll show you. Literally, just take an identity matrix and multiply it by a matrix, anything, make up one, and you'll get the same thing. Like if you do it yourself, you'll get the same thing. Okay, so let's go through, let's determine if A and B's are inverse. Let's finish the second lesson today, that way we can just hit the review next time I see you. Okay, so A is a 2 by 2 matrix, B is a 2 by 2 matrix. Are these the same? I know it's stupid to ask, but we gotta do it. Guess what? They are. Oh, come on. Okay, so they are. What will the resulting matrix be? Alright, so resulting will be 2 by 2. So resulting is a 2 by 2. So this is a good review of multiplication and blah, blah, blah. Okay. So this is part 1. I want to see if A times B, matrix A times matrix B, is going to be the identity matrix. So the first matrix, this is how I get my rows. A is what gives me my rows. So I put the left matrix, right? The one that's on the left side. Here it's A. I'll put it on the left side of my box because I'm going to have a 2 by 2 matrix. And then I'll put B because this is how I get my columns, is from the second matrix I'm multiplying, which is B. So I'll put that on top. So I have 5 times -4, -6, 5. Okay. So I have it all set up.
Wait, what was that? I see how you got the 5, 6, 4, 5. You just brought them to A. What did you just do with it? Why did you put it there?
So A goes, so whatever the first matrix is, it's going to be to the left of your resulting. Whatever the second matrix is, it's going to be on top. And this is why. Are you ready? This will blow your mind. A blue C period's mind. How do I figure out what the, so I have 4, this should be a 2 by 2 matrix. So I have 4 places I need to find the numbers. How do I find what should be in the top left corner? How do I find that value?
Row 1 by column 1.
Yep. So I go through row 1, I go through column 1. Okay.
Is it 25? No.
Oh, yeah.
Well, let's see. So I'm gonna go through this one step by step. So 5 times 5 is 25. And then I'm going to add, so left one, down one. 6 times negative 4 is negative 24. What is 25 plus negative 24? 1. So 1 goes there.
It's right one, down one.
Right one, down, yeah. Now let's go. Can you see where I'm overlapping it? Let's go to where the overlap is now, the top right hand corner. All right, so I'm going to take, oops. So I'm going to take the 5 times negative 6, which is negative 30, plus 6 times 5, 30. What do I get here? 0. Okay, so this is promising. This is promising.
Row echelon.
All right.
Wow.
Let's take this. I want the bottom left corner. The bottom left corner. So I have 4 times 5, which is 20. And then right one, down one. So your fingers are showing you which way to go. Remember that sweet dance move? Oh, la la la. La 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 la. No, okay. You do you. 5 times negative 4. Okay, so that's plus a negative 20. So that's 0. Lastly, okay. Lastly, we want the bottom right corner. To figure this guy out, I'll take 4 times 6, which is negative 24, plus 5 times 5, which is 25. So I start at the very left and top, multiply them, add it to the next, add it to the next, add it to the next. So like you're working your way in. And I write it in this form because then you know exactly which ones to multiply. It's the column above it, it's the row beside it. Should help you theoretically. Okay, so add them and you get 1. Oh my god, what is this? Do you recognize this matrix?
Oh, that's
It's definitely
Identity
Gaussian theorem
matrix.
row echelon.
that's I think.
This is identity matrix. Okay, so guess what? I found that A times B is identity. We're halfway there. We want to prove that they're inverses. In order to do that, I need to now multiply B times A. I have to multiply B times A. Okay, so I'm going to check if B times A is the identity. If it is the identity matrix, if that's what I get at the end, they will be inverses. I will have proven it. Cool. The hardest part of this lesson is like actually multiplying the matrices together. Okay, so B is my first matrix. The one on the left matrix, I write on the left side. So I'll have 5, negative 6, negative 4, 5. All right, so that's matrix B, and A is the one I write on top. 5, 6, 4, 5, and then this is where my resulting matrix will be. Okay, we're getting it, maybe? Yeah, okay. So let's figure out where they crisscross. What number belongs there? Let's see. So I have 5 times 5, which is 25, right? And then to the right one, down one. 4 times negative 6 is negative 24. So I add those, I get 1. Okay.
Like I understand your dancing, but like how do you?
How did I what?
Like I'm not getting like I feel like I keep multiplying the wrong things, and that's why I'm not.
Okay, so I knew I had a place here, here, and here. Okay, I have these 3 remaining places in my matrix. So I highlighted the column that's above it and the row that's beside it. You start at the left, you start at the top, multiply them.
That's above it of the place that you're trying to fill.
Exactly.
I got that.
Okay, so I multiply 6 and 5, and that's 30. Then you add it. You ready? So we did the top, the left, and the top, and then I moved to the right by 1. So I'm at negative 6. I move down by 1. So negative 6 times 5 is plus negative 30. Add them together, and then whatever this is equal to, that's what I put over here. So it's 0.
Guys, good question.
Nah.
For real?
Yeah, what?
Oh, cool. Would any 2 by 2 by 2 by 2 be identity and we're just proving it or not always?
Nope, depends on the numbers.
You want us to show the work of
Depends on the numbers.
Because I remember we did one example that was like a 1 by 3 times 3 by 1. And, like,
And so
it
one
was
of the
just, like,
ways you multiply is 1, and then the other way gave you a 3 by 3.
Oh my god. No, the answer we got was just 1.
Uh-huh. So that's the part, I know what you're talking about. It's this part right here. It's popping up. Do you see? Oh, come on. Okay. Do you see on the left
Yes,
side?
That's the one.
The order mattered. If I took A times B, it gave me a 1 by 1 matrix. If I took B times A, it gave me a 3 by 3. Those are different matrices. And also, this is not identity. Identity matrix are 0 everywhere except the main diagonals are 1. This is not an identity matrix. So therefore, those two are not inverses. Okay. No, what? I really want to we're gonna finish the lesson today. This is the goal. So you gotta be we gotta be on the ball. Yes.
Do you want us to write out 25, that showing your work on how we did our matrix, or?
I mean, it'd be great because the more work you show, the easier it is to give you partial credit in case you mess up.
And then also, is there a way to do this on our calculator?
Yep. All right, so let's go through and let's do this. What? Okay. Sam, please sit up. Noah, question? Maya, question?
No.
Okay. Do we understand how to do this last part? 5 times negative 4, you start at the left side and the top. So I get negative 20. Then you go to the right on the row, down the column, multiply 4 times 5. So it's 20, guess what? 0, not surprised there, because this will end up being the identity matrix. All right, I want to do the last row and column. So I see where they overlap. I'll take negative 20 plus 20. Oh, I'm sorry, negative 4 times 6, negative 24, 5 times 5, so I have 25. So that's 1. No surprise here. Guess what? This is the identity matrix. So we can say, yes, A and B are inverses. All right, perfect. So the last thing we're going to talk about is the last, page and a half of notes or so, is inverse and determinant of a 2 by 2 matrix. So I have A, B, C, D this is my matrix A. A is an invertible if and only if A times D minus C times B is not equal to 0. What's wrong? Okay, so A has an inverse matrix only if you multiply this diagonal, and then you subtract the addition. I'm sorry. Okay, let's restart that. Multiply the main diagonal, and then you subtract multiplication of the backwards diagonal. This is of a 2 by 2 matrix. So if I do A times D, that's literally the top left, bottom right corner, and multiply those two numbers together. Subtract C times B, aka the top right hand corner and the bottom left hand corner. If you subtract them and it's equal to 0, guess what? We don't have an inverse for the matrix. Literally, there won't even be one that exists.
Wait, if you
But-
subtract them, then you get that?
Okay. If you subtract them and you get 0, you will not have an inverse matrix. Alright, so if you take A times D, right, so these are the locations. You take the top left, bottom right, multiply them together, and then you subtract the multiplication of the top right and the bottom left, and you get 0. If you get 0, there won't be an inverse matrix. As long as it's not 0, you will have an inverse matrix. So we talked about how to tell if two matrices are inverses of each other, but now how can you make the inverse? A is invertible. If it is invertible, aka guess what? You found that it's not 0. Then you find the inverse matrix by doing this. You have 1 over the multiplication, subtraction. It's literally just using this formula. You switch the locations of A and D, and then you just make B and C negative. That's all the difference is. You switch A and D, and then you make B and C negative. That's it. So this number, AD minus CB, which is this first thing I was just talking about, this is called the determinant. How many of you guys have heard determinant before? Maybe? Okay.
Did on Alex.
Huh? You say you did on Alex?
Uh-huh.
Blessed. Thank God. See, this is one reason I have you guys do Alex. So you can kind of see it beforehand. So you're okay, I know I've seen it, I can do it. So the determinant is literally A times D minus C times B. If your determinant is 0, you will not have an inverse matrix. If your determinant is not 0, you will have an inverse. All right, so let's find the determinant of each matrix, then find the inverse if it exists. So I need to find the determinant. How do I find the determinant?
Cross.
Yep, so I have A times D, which is negative 5 times 8. So let's find determinant of A. So this is going to be negative 5 times negative 8. Then I'm going to be subtracting C times B. So subtracting 4 times 10. All right, so literally this is 40 minus 40.
0.
So it's equal to 0. So the determinant is 0. So how do I find the inverse matrix? Remember how we talked about that? How do you find
Now there's no inverse.
0, so
It would
can't
be
have an inverse.
0 over 1.
That's what I said.
No,
There's no inverse.
1
Because remember, it said it's invertible, aka invertible means has an inverse. Invertible means has an inverse. So you'll have an inverse as long as your determinant's not 0. If your determinant is 0, you have no inverse. Here we found the determinant of 0, so we have no inverse. We're going to call it singular. A singular matrix has no inverse because the determinant is 0. All right. So let's do the other example. All right. So I'm going to take the top left, bottom right, multiply. So negative 2. So the determinant of A is going to be negative 2 times 6 minus negative 4 times 4. Maybe I should do it in a different color. Okay, simplify this out. I have negative 12 minus negative 16. So aka plus 16. So the determinant is going to be 4. So I'll write that out. Determinant of A, matrix A, is 4. Will I have an inverse?
Yes.
Yes, because my determinant is not 0. If your determinant is 0, we'll not have an inverse. All right, so I have a determinant of 4. Now I need to find the inverse. How do I find the inverse again?
1 over
4 bar.
So A inverse, the inverse matrix is going to be 1 over the determinant of A times, let's see, switch A and D and then make B and C negative. So this is going to be 1 over, determinant was 4, D was 6, negative B, okay, so originally B was 4, so now I'll make it negative. Originally C was negative 4, so now I'll make it positive, and then I put negative 2 here. So I'll go through.
4 times A. What is A?
What? Sorry, what?
Is it in the determinant times A?
No.
Denominator?
Determinant of A. Determinant of A. That's how I write it. Determinant of A. Go through, multiply every single term by 1/4, aka divide it all by 4. So 6/4 is the same as 3 over 2. Well, do you want me to? I'll show you the intermediate steps. There you go. 6 over 4, negative 4 over 4, 4 over 4, negative 2 over 4. So this is 3 over 2, negative 1, 1,
Negative 1.
negative 1/2. And that's it. This is the inverse. And the way we write it is A to negative 1, because that's the inverse. Remember how we did inverse, sine inverse was the negative 1? The inverse matrix C is the negative 1. Yeah, turn it down. Turn it off.
No, that was
No, it was on loud.
We know now.
It's fine. Now you know. Woohoo. Okay. Questions on finding the determinant of a 2x2? It's just like following the steps. All right.
only be like 2 by
Is it gonna evolve into like?
Yes.
3x3. Hey. So literally, ready to do the thing that we just did, but like 3 times.
Wait, what? It's not just you don't have to multiply all 3 numbers?
What?
Never mind. I take it back. Wish I never said it.
That's not what I meant. Okay. So determinant inverse of a 3x3 matrix. Yeah, this is it. We have learning this, example 4, and then that's it for the lesson. And should be okay. We'll have the rest of the time to review. Go over problems if you want. Friday?
When's that their classes?
Ooh, I'm gonna
Thursday?
need to restudy on that.
So
Thursday.
you guys would have been Thursdays if it was
Correct.
yeah.
That's great. I'll end it then.
No.
Maybe Wednesday.
This is H period.
Because D period's last Thursdays, that's why you guys.
Okay. That's such a meal.
Well. Alright,
Test or quiz?
so it's a test. Determinant and inverse of a 3x3 matrix. Alright, so here's our matrix. I labeled it A, B, C, D, E, F, G, H, I.
JK.
You guys have trouble. You three, you trouble. Can't have you two sit next to each other. Can't have you three sit next to each other.
We're just all friendly in this class.
Yeah, I don't know.
Oh, well, come in the second row. You guys are not trouble today. Thank you.
Good job, Dylan.
Good job, Dylan. Yeah, Ty, Sam. Bella, yeah, okay.
Yeah. I really want to sit in on an AP Calc piece because Louis and Bradley seem like so much fun.
You free D period?
No, I'm
Then-
not.
then you
it's
can't-
English, so I can miss it.
I am.
Oh my god, what
What
did that say about
expect?
English?
D period?
I already know it.
D period.
Okay, wait, let's finish your final screencast.
Yeah, we were on a good roll.
Okay, cool. All right, let's go. Let's do this. So, determinant and inverse of a 3x3 matrix. So, literally what I have to do is, this is what I think of. I have A times the determinant of this one. Then you do B times the determinant of these. I'm trying to like color code it. It's kind of like if I zoom in on B, and like if I so I put my finger on B, I like make the T, then I'm gonna have, that's why the matrix B times the determinant of DFGI. Do you see how it's like B times DFGI? Okay, you know what? Maybe this is confusing. This is the way I think about it, but okay. So it's the determinant. So A times the determinant of EFHI. So this is EFHI. Oh my god, it's so slow. Then C. I'm just trying to like show you. C times the determinant of DEGH. It's kind of like you ignore the row and column that C is a part of, and you're taking the determinant of the stuff that's remaining. It's a way to think about it. It's a way to look at it. It's probably not mathematically sound, but like that's the way I remember it. Whenever I look at my matrix, I'm trying to find a determinant of a 3x3. Like, put my fingers over the row and column that like C was a part of. Then I take the determinant of like what was not crossed out. I don't know, anything to help you remember how to do this. Alright, so a quick way to find the determinant of a 3x3 matrix. Reproduce the first and second columns to the right of the matrix. Find the product of the respective diagonals along the rows. So here's the 3 that are positive. Are you okay?
Yeah.
Okay. So these 3 are the positive ones, and then of course you have the negative going back. So you're going to take AEI plus BFG plus CDH minus CEG minus AFH minus BDF. So this literally gives you the same thing as what was up above. Find the determinant of like this guy, then multiply it by A. Find the determinant of the middle guy, then multiply each of those by B. Find the determinant of, yeah, whatever. It'd be easier just do an example.
BFG is the name of the Roald Dahl novel.
What?
It's a good one. BFG. Big Friendly Giant.
Oh my
Roald
god.
Dahl.
Yeah.
James and the Giant Peach. Matilda.
I did a purple pen.
A truly genius graphic novelist behind Dr. Seuss. Some would say the British Dr. Seuss.
Okay, cool, yeah, okay, yep, okay.
We're talking about anything else.
It's teaching us something.
Awesome. Okay. Let's find the determinant of A. Then find if A inverse exists. So first thing I'm going to do is copy the first two columns. So I have 3, -2, 1, 1, -1, 2.
Wish we were on the same page.
Don't listen to her.
Sorry.
I mean, I could.
Shucks.
Shucks.
Whew. All right. So let's start here. What? What now?
Listen,
Oh
I'm
my god.
3 times -1.
3 times -1 times 5 plus 1 times 4 times 1.
Wait. I'm still right.
I kind of like the original way.
You know what? As long as you understand one of the ways and can do it, great.
Oh,
All right.
this is interchangeable with the whole like 1 over that thing. This?
No, it's like the one where she was doing the
This is a 3 by 3 matrix. It's a little different than a 2 by 2.
What is he saying that he
She
did?
showed us
What's
two
the
ways
other
to do
one?
3 times by 3.
Oh.
Yeah. You either can take 3 times the determinant. Okay. Okay. So either I have like, here's a 3 and determinant of those 4. So it's like, okay, take the 3, multiply by the determinant of this. Then I'll take the 1, the determinant of the 2 outer. Then I'll take 0, multiply the determinant of the left. It's the same thing. Okay. Oops, I highlighted it but did not write it. So I have plus 0 times -2 times 2. All right, so these were my pluses. Now I'm going to go through and do my subtractions. So here is my first subtraction. Maybe I should get rid of that green so you don't see it. Okay, so the first subtraction, I'm going to be subtracting 1 times -1 times 0. Subtracting here. Yup, okay. Minus 3 times 4 times 2. Subtracting here. 1 times -2 times 5. Okay, cool.
Wait, hold on.
What? What's wrong?
Are you okay, Dylan?
-2 and -1.
Did I like make a mistake? I don't know.
No, you're good.
Yo, okay. So here, -15 plus 4 plus 0 minus 0 minus 24. What? Tall, why are you talking?
No, she asked me a question. My bad.
Okay. -15 plus 4 minus 24 plus 10. You get -25? Where? Right here? Because I'm like doing the stuff.
That's why.
Determinant of matrix A is equal to -25. So, if you go to the previous page, blah, blah, blah. But we want the determinant. So we want the determinant. So if we take the absolute value of A, it will be the absolute value of A. That's another way of saying determinant. Like, it's not absolute value, but it's like the absolute value, like lines. That's how you denote determinant. That way you don't have to write DET parenthesis, right? Just put the little, that's what it means. Okay, that's what determinant means. Okay. Yeah, you know, it is what it is.
Is there a way we can do that for the 2x2s?
All right, so,
Because that was easy.
I'm sorry, what?
Is there a way we can do that kind of easy thing for the 2x2s?
What do you mean easy thing?
Like we added the 2 rows, we did the 3 things. and
Yeah,
multiplied.
well, 2 by 2 is much easier. We're almost done. We have to find the inverse if it exists. All right, that's the last part of this problem is finding the inverse if it exists.
There is no.
Do you do that with the same
It is.
equation?
Do I need to multiply two equations for there to be an inverse?
Maybe like 1/-45.
What?
There needs to be a B for you to do AB times BA, but here it's just an A.
Did you guys get this far in the screencast?
Yeah, we finished it.
Okay.
This is what we did. We didn't find the.
You didn't find the inverse?
No.
Do there not need to be two matrices to find an inverse?
No.
So how do we find the inverse
That's
of
the
this
3
one?
by 3 and
Can we do it?
What?
Real fast, why is number 45 stars?
45.
41 and 45 homework.
Oh.
Might be a little challenging.
Oh my god.
Okay.
On the what, 6.2, Adam?
Yeah.
You started two of them?
Correct.
Just do
Just
that.
one, just one.
That's 45, but on both sides.
Okay. Cool. Okay.
Ding.
Yeah. What the hell? What are you doing?
Waiting to enter.
So the way you find it, more or less, you use this. So how do I describe this without totally confusing you and making all the progress we did moot?
Huh?
I'm just trying to explain how to do this without like confusing you.
Solid. Let's do it.
I noticed that identity
What's wrong?
matrices and friends.
Wait, you assign the value.
What?
With time.
What's wrong? It's coming. It's coming.
Jeremy, what did you say?
On the matrix,
It's unimportant.
on the matrix above, you each one of these letter value, and you put it in here. Do the same thing. Assign letter value, put it here, and then it's equal.
Yeah.
Are we doing it or not?
Yeah.
We're doing it.
So yeah, for 2 by 2 it's a lot easier than explaining what the 3 by 3 would be. I'm gonna explain how I got this.
Hey, that's what I said to do.
What did you do?
Multiply by 1/25.
Except I'm not exactly multiplying over 1 by 25.
So it's negative 25.
No, because negative 25. The same thing as negative 25.
Yeah. Alright, so it's just like the 2 by 2 matrix. Literally the inverse is 1 over the determinant of A,
Which was 25.
negative 25.
Yeah.
So did I not write? I wrote the negative. Negative 25. Alright. Times. Okay.
So it's that times.
Yeah.
Oh, and then you do it to all the members? That's not bad.
But she still hasn't
You
said
do,
so.
but it's not just multiplying them all by 1 over 25.
Oh.
So if you notice, it's not all just divide by 25. Yeah.
Oh, frick that.
Where did you choose
Yep.
these numbers from?
I don't get it. Wait, so what do we do? How do you do it?
I don't get it.
No, that's not it. There's things you switch around, but we don't.
There is.
What?
So for the scope of this lesson, you can just use your calculator to find it. You don't.
Yo, freak
It's
out.
because it has a 7-second delay. That's why. Because it's been recording for a while now. Okay. So as far as
Yes.
the scope of this class, they'll let you use a calculator. I'm not gonna make you memorize this humbug, this craziness. So if you want to get out your calculator, we could do it relatively quickly. But it might be, there are directions in your book on how to do it. In 6.2, there are directions on how to do
You
it.
did?
Will we have a calc on the whole
Okay.
test or no?
You can?
I'll describe it to you tomorrow.